Hello everyone and welcome back to advanced feature of OPCloud. In today's session we're going to talk about how to operate the ROS connection with OPCloud. As you can see, we are loading our example of a ROS connection with some kind of operating robot. In this example, we're using the turtlesim, which is an example part of the ROS architecture and ROS packages. First, let's go over how do we connect, working together with ROS and building a model that can help us simulate and do operations and connect directly to robots. Please note this is an advanced feature, so you must have some knowledge about ROS architecture, a little bit about robotics, OPCloud, and so on. But let's get a little bit further in our way. First, let's discuss a little bit our model. Our model is a model of doing a spiral way with a robot in this way, in this example, the turtlesim, and we can manipulate and send messages to the robot via the connector to the ROS master and receiving messages from the ROS master if we need to. In this example, we do not receive, we only send messages. So we have here the SD main system diagram, and we can drill down, and you can see that we're getting from the user how much depth do we want to have in our spiral, and we can take it and check it. Once we have the depth, we're performing the spiral. You can see that it has conditions. Did we finish? Did we not finish? How we're doing loops with counter and so on. And then we have the actual message performing. We're creating the message according to what we need. This is the message to be created, and then we can publish it. And this is the publishing message, and then we do the finishing part, which is checking whether we finished doing the counter, the iteration, and if not, we finished it completely. Once it's finished, it will select what to update to each part of our model. Now, let's drill a little bit to the model itself. First, let's see how we create a message. This message is creating via our code itself, just building it, and I will open our built-in IDE of a code in our model. It will open and show the code that we currently have. You can see we discussed it in previous videos that you can, everything that's connected, and you can update and use whatever you want to do. So here we're building the message, which looks like that, and we're taking the counter and adding some kind of an angle into it. Nothing important. The next part is the actual ROS publishing. When you're doing computations, there is several options, and this is the ROS option. This in the model it's already done, but if you want to create yourself, you're going to create a computational process, then click on the ROS, and you will see that we have the ROS messaging screen. You can see that we have publish, subscribe, service, or general ROS script, and then you can use your topic, data type, and message. And you can see we have the tooltip. If the message is empty, it will be only from connected to the computational objects that's connected to it. If not, it will take the actual message here. Since we're building the message here, we will not put it in the message field of the screen. You can see that the topics are building as needed, but remember, we can use aliases and connected object to build our own topic on demand, on the fly, meaning that if, for example, I had a computational object with alias A with the value turtle1, I will be able to use, instead of turtle1, A, and the value will be taken from object A and will be used. Please note that in the ROS message, we split by the tag slash and take each value of its own and check whether it's an alias, and then we use it as an alias, or is it just a string, then we do it as a string, meaning that here we can use two aliases and here we can use two aliases. So this is how the message is operated. You can do whatever depth that you want to do in publish according to the topic and data type. And if you're using service and if you're using a ROS script, you can just write your actual message as it is. Now, let's move forward. How do we connect to the ROS master and what are the permissions? If you're going to the setting menu, you will be able to see that in the OPCloud setting, each modeler has its own options. You can see that we connect to the Python server, the ROS server, and the MQTT. Here we can define it. In general, the default values are localhost and 3000. You can change it unless your organization admin decided not to change it and everyone will use the same one and so on. So you can use that. While you change it, it will be saved as your preferred connection details. Then you will be able to go to the connection group. You can see the WebSocket connection group. We have the Python, MQTT, and the ROS. You can see that it is localhost and port. You will need a connection, WebSocket connection, to use as a mediator between OPCloud and your ROS master. For that, under OPCloud manuals and guides, you will be able to see that we have several guides. You can see the introduction and user guide, of course, but also you have the built-in code for your use if you want to use the Python or external function and so on. And you have the MQTT and ROS connection WebSocket server, so you can download it directly from OPCloud and use it and change it if you need to, according to your needs. Now we go back to our model, and we already started the ROS master, and we already started the WebSocket connection. So once we will click on the ROS connection, you will see that the WebSocket connection is established, and the color of the button is currently changed to show that it is connected and working. We can close the group if we want to. The next thing we want to do is to change into our simulation mode. We'll click on the simulation, and we have again whatever we need in the simulation, regardless of is it a ROS or not, and you can of course mix and match, and you can use in the same model connection to MQTT and ROS and Python and user-defined function and external URL and so on, and later on we will have more options to connect to. You can use the simulation option to select if you want to simulate it or not. Currently, we're not simulating it, so we will be using the actual and connection details. And once we will start, I will show you that we have the turtlesim, and I will put it here on the side so we will be able to see it, how it's working in real time. And we can start our simulation. So let's start it. Once I will click it, and then I will bring it up. You can select the speed. Please use the synchronized execution in order to see it in real time. So let's start with our demo. You can see that it's going up, and then we're getting our value. Let's put a depth of 4, getting the option from the user. I will put back our turtlesim, and you can see that it generated a message, and now it is publishing. And you can see how it is now working with the turtlesim. I will move it to the other side so it will be easier to see the calculation with the counter. Now, as you can see, the counter is getting up and updated. Now it's 2, and the message is updated. And you can see that our turtle is having a nice time traveling. And you can see that it is currently on the partial part, and you can see that we have condition, so it is continuing, and now it's number 3, and it is getting updated, and the spiral depth is increasing, still partial, and now we're getting to the last iteration that we selected, 4. So it is updated, another spiral is done. Now we're in the finishing part. You can see that it is increased, and we're going back, and now it is completed. So instead of partial, it is back into our options of completed. As you can see, we've finished our execution, and we can now do it again, and so on. There is current limitation, as we said. First of all, please note that there is time taking between one option and the other, and there is a limitation of doing parallel execution that we will show you once it is ready, and you will be able to operate multiple agents, multiple robots at the same time, and having the robot both receiving and transmitting messages using ROS. I hope you enjoyed this demonstration, and we'll see you again in the next advanced OPCloud feature. Have a great day, and goodbye.